Guys, what's up and welcome back to the channel. This is the Prokon Geek, and in today's video we need to continue with our flat slab design series where we are looking at the design of flat slabs using both AutoCAD and Prokon. So this is part 2 and we need to continue with what we did or from where we left off in the previous video. And to do that, today's video we're focusing on just a few things. What we need to do is we need to do a recap. Then we need to address a couple of things from the loads. Then we need to go back to AutoCAD, see what we do with the next step, then come back to Prokon, and then lastly go into Prokon paths for some detailing trips. So without wasting too much time, let's just get right into the video. Okay, so as I told you in the introduction, we need to do a recap today. So if you remember what we did in the previous video, obviously now as you can see the DWG has changed, because what I did is I went ahead and already did the steps for you so that we just do it quickly in our time and we don't waste too much time following what I'll be doing. But just to recap, in the previous drawing we only had this one line which was called reference and the one which is called phase 1. So if you remember what we did is we started off, this is to be phase 1, which I call strip A in LY. We started off with the layout. Then the first step, which is step 1, was what I call establishing the midpoints, where we established these gray lines, right? And this led us to establishing what we call the slab strips. So this was step 2 and it is called establishing slab strips, and we were establishing them in the direction LY. Now, as you can see, this is LY and we established 3 strips. We had strip C, which is the external one, then strip B, which is also the external one, and we had strip A. After we had done that, we also established slab strips in the LX direction, but we said we were going to look at this in a later step. So what we decided to focus on the LY direction, and after doing that, we isolated the central strip. In this case, that was strip A. So after isolating strip A, we went further. This is now step 5, right? We went and established the column and the middle strip, right? I showed you what is the column strip and what is the middle strip, and by hatching the column strip and middle strip, remember the green represented the column strip and the orange represented the middle strip, right? With the given dimensions as you can obviously see on the screen. After that, we went to the step that I called taking note of your span, right? And we established that our slabs were 5,000 by 5,000 and were identical throughout, and that helped us to calculate the depth of the slab. If you remember in MathCAD, I'll try and pull up a MathCAD sheet right now. Slab depth, there we go. But we established the depth of our slab was going to be 250, and after that we went into Prokon. Now, there's one thing that I wanted us to do, or just go back to input. We talked about everything about how to put in the input. In this case, I just think I forgot to say this is going to be strip A in LY. We discussed everything of these inputs. We also discussed where 5,000 came from and where 250 came from, right? Just to recap, if you forgot 5,000, right? Where is my AutoCAD? 5,000 came from the slab strip. So if you remember, if you isolate the central strip, if you see, the entirety of the strip from this point to this point is indeed 5,000, and it's 2,500 to one side of the column and 2,500 to the other side of the column. So that is where 5,000 came from, because the slab strip that we're analyzing is going to be 5,000. But in the slab strip, we're going to have a 2,500 column strip and 2 middle strips, which will also total up to 2,500 if you add 1,250 and 1,250. So now you understand where 5,000 and 250 came from. And then the spans, we also talked about this 5, 5, 5, 5. If you remember, if you look at the spans, it's definitely 5,000, 5,000, 5,000, and 5,000. And that is in millimeters. So when it all comes to meters, all you need to know is you divide by 1,000, right? And the section is going to be the same throughout. Then for the supports, we talked about having columns and having simple supports. We also talked about that columns reduce the moment that will be experienced by the slab. So if you want to be on the conservative side and you want maximum moments to be taken by your slab, just model them as simple supports. Now the most important thing that I want to do, as I mentioned to you, we need to address the loads. Now if you remember when we were calculating the loads, this is the Excel that we used. Let me just put it up. Oh, there it is, right? The Excel that we used is we had the slab thickness, then the screed thickness, and then the unit weight of concrete and the unit weight of the screed. Thus, the slab from the load was going to be equal to 1000 divided by 250. This is just to make sure that we are using meters. And then you just multiply that by 24, so that, because remember, gamma is kilonewtons per cubic meter, and when you multiply it by the thickness, which is millimeters or even a meter, all you're doing is you're removing the cubic and transforming it into a square. So same thing applies for the screed. You just multiply by the unit weight of the screed, multiply by the thickness of the screed. In this case, you get your load. Now, to get the load, since you have to remember, this one is treated as if it's a beam, and you are treating the load as kilonewtons per meter. So to get that load in kilonewtons per meter, what you do is you then multiply by the length of the slab strip, in this case, which is 5. So remember that your slab strip is definitely 5 meters. 1250 plus 2500 plus 1250 equals 5000. If you want to recap, there you go. There is your 5000. Divide by 1000, you get 5 meters. So that is what you saw, and we multiplied it, in Excel, right? So the load from this for the slab is 30 and the screed was 5.75. In this case, I don't know why we even had 37.5. It was supposed to be 35.75. So it was supposed to be this. But then again, before we proceed, this is what we had done. Now, one thing that I had forgotten or that I overlooked is that this is the normal procedure when you're designing a beam. You want to have the load from your slab and the screed go onto your beam. But unfortunately, this time our beam is the actual slab. And remember, this program calculates the own weight factor given the section that you entered. So it will calculate the self weight of this slab or whatever, the beam, right, on its own. And in this case, we are not designing for a beam, we're designing for the slab. So this component became useless because Prokon was already going to calculate it for us. So what we did is we actually over-designed or overloaded the previous slab that we did in part 1. And that is what I wanted to address. So in actuality, this was not important. The only load we were supposed to enter was 5.75. So remember when we had our loads like this, when we saw the deflections and everything, this was 15.31. And when we came to the reinforcement and when we reinforced it, right, I think in this case we discovered we needed 17 bars at this position, because remember 8 plus 19 is equal to 17 y12s, and we divided that by the spacing. In this case, since it was for the column strip, that was 2500 divided by 17, which gave us a spacing of about 125, which is what we didn't want to do. So in this case, what we need to do or address is what we need to address the loads. This needs to change, and in this case we now need to put 5.75. So in this case we are putting 5.75, then Control C, Control V, Control V, and Control V. Now this is the actual load. Now this is a good thing. What you need to do is also just remember, this is a, you also need to put the description. That is why descriptions are quite easy. They help you to remember what load this is coming from, right? So I would say this is the screed or any type of finishings that will be there. And remember, this is the live load. We're just going to say this is the live load, so that we remember what this 10 is coming from. So if we had input slab and screed, we could have easily identified that no, we made a mistake, but last time we just bunched everything together and overlooked that step. Now, once you have done this, the next step is you've changed the loads. This is what I wanted to address. So let's just see what the final results are now. So remember, you don't have any wind load. Now you go to view. As you can see, your long-term deflections have decreased from 15 to 6, which is now good. And your moments, yes, remember, this is where you just check, but the most important thing is for you to go to reinforcement. Now, since we have changed the loads, you need to regenerate this reinforcement. So just remember, your minimum bar diameter at the top is going to be 12 and the maximum is 12, because what we want to do is just want to load the slab with 12 millimeter diameter bars. So in this case, same applies. Even for the stirrups, you just want this to be the maximum. You'd actually want it to be 10. Right, although we are not actually going to be putting any stirrups, as you see, most of the times the concrete section is able to take care of the shear on its own. In this case, what you're going to do, concrete cover to the sides, you also want to make it 30 so that it is quite uniform. And next thing is just going to press on generate reinforcement, and existing bars will be overwritten. Do you want to continue? All you have to do is click yes. Now, as you can see, you no longer need 9 bars. You now need 8 plus 2, which is 10 bars over the section. But if you go down and look at the section, it is the red envelope is too close to the moment. So preferably what I would want to do is change this from 2 to 3 Y12s. And as you can see, now the envelope is a bit higher. Same applies when it comes to this direction. But in this direction, what you could do is you can take it down like this. Then bring this 8 bars, which is saying 12. Then just extend this to this position, right? So what we're going to do is, the important thing is just for you to note the number of bars that are needed. So same applies there. I'm just going to change this from 2 to 3. And the moment envelope goes up, then same applies here is just telling you you're definitely going to need some bars over this section, bars over this section. So what we're going to do is we're going to print out this, and this is what we're going to use when it comes to detailing, so that we know the areas that need bars and the areas that are not mostly affected. So in this case, as you can see, we can even lessen the steel that we will have, and to just see what the spacing will be. In this case, we have 8 Y12s by 3 Y12s. That will give you 11 bars. And remember, we are detailing it as a column strip, and the width of the column strip is 2500. So what we're going to do is we go back to Excel. Then we're going to see what is the width of your slab strip. In this case, the width of our slab strip is 5000, right? And therefore the column strip is 2500 and the middle strip is going to be 2500. So in the column strip, how many bars are required? In this case, we need 11 bars. Therefore the spacing we need is 227. So normally the best spacing that you would use is 225, but unfortunately once you go past 200, you cannot use increments of 25, so we will need to go with 25. So all we need to do is go to rebar and spacing tables and just wait for it to come up, and there we go. And then we go to the second table, right? And now we see what we do need is see what the spacing will be. As you can see, we get Y12s at 225 is available, but when it comes to detailing using the British or the South African code, you are supposed to now start going from 200 to 250 to 300 and so on. I even have a video on this. If you want an explanation of how you need to detail, I've left a link in the description box, so just click on it. That will be probably the third line, right? That is for detailing all the basics of detailing when it comes to the South African and British codes. So this is probably the gist of it. So we're going to be providing Y12s at a spacing of 200 to give you an effective area of 565 square millimeters per meter. So that is what we're going to do at the top. Then at the bottom, all we need to understand is, let me go back. At the bottom, if you go to the main reinforcement, it says we need 8 Y12s. So what it is just saying that in the column strip, if we need 8 Y12s, go to the right Excel, and you will see that at the bottom, we are going to use a spacing of 300. So at the top, we'll be using 200, but at the bottom, we will be using 300, and this will be in the T or B1 and T1 layer. So now that you have understood the spacing that you're going to need, what you will then do is in the column strip, you know the spacing, then you will go to pads, right? And in pads, make sure you already have your layout drawn in pads, right? In this case, this is the same layout, right? If you go and check in AutoCAD, this is the same layout where we have 20,000 and 10,000, which is a 20 meter by 10 meter slab, and 5,000, 5,000, 5,000, 5,000, 4 panels of 5,000, and in this case, we have 2 panels of 5,000. And if you go to pads, that is the same setup, 5,000, 5,000, 10,000, right? Then 5,000 by 4, you get 20,000. So this is just for notes. As you can see, I've put this for notes. This is for general, just to remind me that this is the middle strip, this is the column strip, and this is the middle strip, and this is slab strip A, right? And this is when it's different when we're now doing slab strip B and C. So what I've done is I've separated the layers to say slab rebar B1 and slab rebar B1 as well, but then this is for strip A and this is going to be for strip B and C. So remember, strip B and C are identical, right? Because they are both 2500 and 2500, and they frame the slab the same way. So all you have to do is go back to pads, right? And also I have separated the T1 layer for the slab strip A and for slab strip I was supposed to separate this one for slab strip B as well, right? Then what you're going to do is, in this case, now you know the the reinforcement that you need in column strip, in the column strip. So what you would do is, before we actually start reinforcing, all you need to do is, since you have your notes, what you're going to do is copy this text, bring it to where you have the strip, which is down there. Then we're just going to leave a note here, and we're just going to say, in the bottom, what we're going to need is, we need Y12s at, let me just put it nicely, at a spacing of 200 millimeters. Actually, this is at the bottom, so at the bottom we need 300. Remember that, don't confuse the two, right? And this is will be it for the, or you can just say column strip to make sure that you don't forget. You need column strip will be equal to Y12s at a spacing of 300, right? And then you copy it. This is for B1, and this is going to be for T1. So now that you know that at the top you will need Y12s at a spacing of 200 millimeters. Actually, I was supposed to say millimeters there. Then this is what you do, and then you come back to the other top as well. Make sure you indicate this is going to be at a spacing of 300. So if you really don't want to forget, just remember, you can always copy this, then pre-3 it, bring it there, then edit, then always, so that you don't forget that this is going to be for the bottom layers, right? And maybe change the text to 10 so that it is quite visible. This is going to be bottom layers, so B3. Then you go there. Then once you get, this is going to be for the top layers, so that you also have the notes and you remember as well what you will be doing. So now you will know that in the column strip you will need, in the bottom layer you will need Y12s at a spacing of 300, and in the top layer you will need Y12s at a spacing of 200 millimeters, right? Once you've done this, now we also go back to Prokon, and you go to digital, and then you now change this to 4, because you now need to detail it as a flat slab for the middle strip. Then you say generate reinforcement, existing bars will be overwritten, yes. And in this case, you now take note of the bars that you are going to need, right? So you go to the worst case scenario, right? And in the bottom, at the worst case scenario, you're going to need, this is 8 bars plus 4, so that will give you 12 bars. So just go back to Excel and type in the column strip, you're going, no, this is now the middle strip, so this is going to be 12. You're going to need your bars Y12s at a spacing of 200 as well. And going back to Prokon, at the top, this means 3 Y12s plus 8 Y12s. That means 11 bars, and 11 bars are still going to give you at a spacing of 200. So what it just means is that in the middle strip, at the top and at the bottom, you need to provide bars or Y12s at a spacing of 200. Same applies there. You can see 4 Y12s and 8 Y12s. That gives you 12 bars, and it will be needed at a space of 200. So same applies even in the middle. It's even better because you have 8 bars and then you have 3, so that's 11. So we're going to be using the worst case scenario. But what about at the top? So now you look at all the columns, all you need are 11 bars and 8 bars. So all you have to do is go back, and if you check, 11 bars still give you a good spacing of 200. And remember, you need to go with a spacing that's less, not the spacing that's more. So 12. So you're going to go with the worst case scenario. In this case, we'll be providing Y12s at a spacing of 200 in all directions. So all you have to do in the top layer now, for this is, remember, this is now for the middle strip. So you copy it, and you now come, no, you come, this is the middle strip. Remember, this is the middle strip. So what you do is you then say middle strip Y12s at a spacing of 200, right? We're going to detail it much later on, but for now, this is what you need to do. So just copy there, and if you want, just move this to a little bit central space, and there you go. You're going to need this at a spacing of 200. That is okay. Then the same applies. Remember, it's the same spacing for the top and the bottom. So you copy it down to the bottom, and you're going to say the middle strip, you need Y12s at a spacing of 200. And this this is actually at the top. At the top, you also need column strips Y12s at a spacing of 200. So all your bars in this region will be spaced at a spacing of 200 and you'll be good to go. So this is what you do for the first section. So what we're going to do is we're now wrapping the video here, right? Because we've done the first steps and now you know what you're going to be doing. So what we're going to do in the next video, since we haven't even detailed the slab, but we now know the spacing that we need to put for the steel. We now need to continue with all the other slab strips, right? Remember in this video we just looked at strip A. We now need to look in the next video, we need to look at strip B or C, and just remember they're similar, so we need to do them as one. So what we're going to do is when we come back, we're going to go to phase 2, phase 3, phase 4, phase 5, and then phase 6 will be lastly detailing the freaking slab in Prokon plaids. Yes, sometimes I do talk myself, so I call detailing the plaids in you Prokon Slab, you Prokon Geek back clad. But anyways, that is going to be the next video. So thank you very much for tuning in. We'll still continue with our slab series, flat slab series. So see you in the next video, and until next time, stay safe, don't sneeze, and please subscribe.